Good morning, everybody. And it's great to see the room packed. There's a few extra people coming in, but I think we can get started. My name is Alberto Faronato. I'm Director of Product Marketing for Storage Products at VMware. I'm joined today with my colleague here, Vijay Ramachandran, Director of Product Management for Storage Products, to talk to you about our software-defined storage vision and walk you through some of the high-level announcements that we've made this morning. This is an introductory level session. We're going to stay a little bit at the high level. I know that many of you go deep into the technologies. We have plenty of sessions in the storage track that will satisfy your appetite for all the technical details. We'll try to provide more breadth than depth in this session. Before we get started, I want to just make sure that you know about the most important item of the presentation, which is that we're giving away the T-shirts, official VSAN T-shirts, on your way out. So make sure that that you pick one up. So what's the agenda for today? We're going to start with going over a little bit of the vision itself. You heard the high level from Pat during the keynote. We'll add a few more commentary and details around it, and then I'll summarize the key product announcements that we've made today. I'll then turn it over to Vijay to walk you through some of the key products in a little bit more details. You know, this is my sixth VMworld. It's amazing how time flies, but it's been incredible for me to see how, in the last couple of years, especially, storage has become such a big component of this conference. I think we've put together an excellent program for you guys that are interested in storage. We have 38 sessions, most of them delivered by partners. We have over 10,000 pre-registered attendees to this session, so it's definitely an area that has a lot of interest for VMworld attendees. Now, by show of hand, how many VMware customers do we have in the room? Awesome, pretty good number. And if you don't mind me asking, how many storage admins? Okay, good number. How many vSphere admins? A little bit more. How many of you do both? Pretty much everybody, fantastic. Okay, this is great. So I hope that we're going to be able to show you some of the key technologies that you're going to be able to leverage going forward to really address some of the challenges that storage faces today. This is a pretty big crowd, so we're going to try to walk through the content first, and then at the end leave enough time for Q&A. So hold on to your questions. As you heard from Pat this morning, virtualization had a pretty big impact on storage. And gone are the days where we had application very statically mapped to data stores, LUNs, or mount points, where we could basically manage quality of service on a one-to-one basis for each individual application. The number of objects in your environments that you had to deal with were limited to a handful of LUNs. With virtualization, things have changed significantly. First, with the coming of server consolidation and the usage of features like vMotion, external storage really proliferated in the data center and also became more challenging to manage. Virtual machines consume storage through what we call virtual disks, or VMDKs in the case of VMware, and these objects proliferated just like VMs did on the compute side. So now you have thousands of objects to control in your storage layer. Virtualization also brought changes to the profile of the storage workload. In particular, you heard from Pat this morning of this problem of the I/O blender. Basically, all the I/O paths coming into the hypervisor and being mixed with each other from different applications that move around and making things particularly challenging for the underlying storage infrastructure to handle. Magnetic disks really don't like random I/O that much. And so things became more complicated. Now you have to manage quality of service on a many-to-one basis through constructs like LUNs and mount points that were really designed for the physical infrastructure. Virtualization is not the only thing that is impacting storage and driving change. You heard from Pat this morning on the both application level as well as the storage infrastructure level, there's increasing diversity. With respect to application, it's not just about traditional applications anymore. We have this new breed of applications that we call next generation cloud applications. These apps tend to have very different concepts around storage. They tend to be scale-out applications. They tend to like leveraging direct attached storage. They come with specific application constructs that deliver the resiliency and the availability that was once delivered to the applications directly from the hardware. And so this makes things complicated on the application side. The complexity even increases a little bit more when you look at the storage side. And there's several trends there that are affecting the storage layer. Flash is a big trend in the market, both with respect to external storage arrays. Any mid-range storage array today comes with a good amount of solid-state drives already packaged in. We have new forms of all SSD arrays, and Flash is emerging as an important tier also on the server side. We have new forms of storage like object storage, primarily today accessed through the cloud, but in the future potentially also accessed directly in the data center. And a new form factor, a new breed of storage array that we call virtual storage arrays. These are form factors of storage arrays running, of storage software running inside VMs on top of a hypervisor. Think of HP Store Virtual, or NetApp's Data on Tap Edge, or some of the early versions of EMC Virtual VNX. So vendors are experimenting with the idea of running storage software inside a VM. So all this complexity makes it really hard, gives a lot of opportunities, but also makes it really hard to match the right storage to the application. When we talk to our customers and ask them about what are their challenges with storage, we hear a lot of issues, but primarily they revolve around the three key things you see here on the left side. In no particular order, number one is management, and what we hear there is that there's really a lot of guesswork going into configuring the right storage. Operations tend to be extremely manual and siloed on a device-by-device basis, each device coming with its own management infrastructure. And overall provisioning is too slow for the expectations that virtualization and cloud are driving. Number two is performance. Performance, as we mentioned, has become very unpredictable and difficult to manage. We hear that it degrades with time. And that there's a lack of end-to-end visibility from the virtualization layer down to the infrastructure layer. This makes it hard to do troubleshooting and monitoring when issues emerge. Lastly is cost. And we hear a lot from customers that they're often looking at over-provisioning to get performance. They find inefficiency in terms of overhead for management operations, and they have challenges when they want to take advantage of direct attached storage opportunities for lowering costs. Just by show of hand, how many in the room think that management is the most critical pain point? Quite a few, not too many. How about performance? Many more. How about cost? Like performance. How about all three of them? All right. Okay. So the objective here that we have at VMware is really to drive forward the agenda in terms of innovation to really break these silos, help you match the right application, the right storage to the application, and increase efficiency. So why can VMware help? I really think that it starts with the position of the virtual infrastructure vSphere in the stack. vSphere sits right between the applications and the underlying hardware. And so because of this unique spot in the stack, we have complete visibility about the application needs as all the I/O traffic goes through the hypervisor. we have this knowledge in real time, so we can also do and leverage that information much faster. From an infrastructure standpoint, we are a hardware agnostic layer, and we have global view of the infrastructure as we connect with most of your storage devices in the back end. So we really think that leveraging this unique spot in the stack will help us drive significant innovation and solve the problems that we just talked about. Many of you may not think of VMware as a storage company, but in reality, as Pat talked about earlier today, we have invested a ton of engineering resources already to try to address some of the challenges that customers are facing with storage. You probably are very well familiar with constructs and features like VAI, the APIs for array integration, the APIs for storage awareness, the VASA APIs, features like storage vMotion and storage ERS, which are very popular among our customers, as well as data services like vSphere Replication and vSphere Data Protection that we offer through the platform. These clearly are not an all-encompassing and conclusive solution to the problems, but it's the starting point that gives us deep knowledge and understanding about issues and storage so that we can take it to the next level with software-defined storage. What is the objective of software-defined storage, and what is software-defined storage? The key objective at the high level is really to bring to storage the same operational efficiency of the model that server virtualization brought to compute. And so to achieve this, we want to abstract the heterogeneous resources, storage resources in your environment, present them as logical pools of flexible capacity that can be consumed and managed through what we call an application-centric, policy-based automation. Now, this is kind of a long definition, a little bit of a mouthful. So let's go into the details and see how this works. The first component of our strategy is the policy-driven control plane. And the objective here is to move the control plane, move the management from a device-centric world, like where we're at today, to an application-centric world, as where it should be. You're probably much more familiar than I am in all it takes to get some storage provision to your applications, but from what I hear, typically what happens is that the application owner kind of, wants to provision a new app, does some application gathering requirements, and then it goes to the storage admin and requests a file system or a data store in general to kind of provision the application against. If it's if a tier 2 application, not a high priority one, chances are that the application will share a file system with others. If it's a mission critical application that requires assured quality of service and performance, most likely what's going to happen is that we will want to assign a set of dedicated resources to it. So basically carving out portions of resources through a dedicated LUN or a dedicated file system and mount point. So in this case, the storage admin basically goes back and does what we often hear called as the spreadsheet black magic. It has to figure out how to configure the backend data store and find out where the resources are available across what's available in the data center in terms of capacity and in terms of throughput. It then has to create the LAN, assign the right rate levels, assign the data services, and provide access, doing the appropriate zoning or LAN export, mount point exports. All this is a very manual, time-consuming effort that can be undermined very quickly as soon as the application is running and you find out that you need different things. And so you have to go back, reprovision storage, and migrate the application, which is huge pain. So we want to absolutely change this time-consuming and inefficient model into a much more automated and VM-centric, application-centric model. And this is really the objective of the policy-driven control plane. The first thing that this component of our strategy will allow to do is to specify the attributes, the characteristics of each individual VM through what we call VM storage policies. These may be things like specifying what type of capacity you want, what type of performance you want, level of availabilities, maybe some of the advanced feature data services like caching or replication. And this policy essentially becomes the unique identifier of that VM from a storage standpoint in your environment. Think of it as an identity card, if you will. The policy-driven control plane will then take this policy and with built-in intelligence will be able to do a number of things. First, it's going to be able to place it on the right tier of storage, doing intelligent placement, automated intelligent placement. Second, it will auto-provision transparently all the data services that are necessary to deliver the quality of service that you specified in the policy. And lastly, and this is extremely important, it'll be able to build a closed feedback loop with the underlying infrastructure, so as things change in the environment, you'll be able to monitor compliance to your policy and take remediation actions if things needs to change. Now, to complete this provisioning picture and ongoing management of a VM with a VM-centric model, we need to be able to provision data services, advanced data services like replication, snapshots, or backup, for example, at the VM level through an application-centric data services model. And so this is the second component of our strategy. Really what we want to enable is an extensible framework for third-party integration of data services to be provisioned and managed at the VM level. We want to make this a broad ecosystem-driven trend, and so we're working with all our partners to try to drive towards this vision. And what will end up happening is that the end user, based on the different services and data services that are available in its environment, will be able to provision things like replication directly from the array on a per VM basis, or leverage vSphere delivered data services, like for example caching on a per VM basis, or leverage data services that are being virtualized and run into virtual appliances on top of the hypervisor, like backup, for example. And these are just three examples. The list could be and is much broader. The last component of our strategy is what we call the virtual data plane. And the virtual data plane intends to abstract the plumbing and present it into to the applications into pools of capacity that can be easily consumed. So this is the first objective. It's similar to what the hypervisor does to the compute side. That will eventually enable a much more flexible resource management. Now, there are two other things that we want this layer to provide. One is the ability to drive VM-centric operations, and so develop the right integration points with the underlying infrastructure to be able to deliver a VM-centric model. And second is to expose into vSphere the characteristics of the underlying infrastructure so that the policy-based, the policy-driven control plane can do the right placement and the right management of the resources. Now, when we look at the universe of resources that are available in the data center, we think that things will move towards two key tiers of pooled capacity. The first one is clearly the external storage pool. This is what we're very well familiar with. We're working on initiatives with the entire ecosystem around presenting this pool in a much more flexible way, things like virtual volumes that you heard this morning. This pool will continue to account for the majority of the data center capacity. It's primarily, not uniquely, but primarily a capacity-driven tier where most of the data will stay long-term. As you heard from Pat, the second objective here from us is to unlock the possibility of now introducing a new tier of pool capacity that we called converged infrastructure. And this is really where virtual SAN plays a critical role as a first step. Converged infrastructure wants to take advantage of the trend of the emergence of server-side flash to deliver a converged compute plus storage layer that is primarily performance-oriented, that we think is going to be extremely useful in a number of use cases where data needs to stay close to the compute side. So, summary picture of where we're going to be once we achieve all our vision. Three key tenets: policy-driven control plane, common management model to drive policy automation and VM-centric operations. virtual data plane to abstract and pool heterogeneous capacity and heterogeneous storage devices and present them as pools of capacity, with two key tiers that we see emerging: converged infrastructure and external storage. And lastly, application-centric data services to deliver advanced data services on a per VM basis. Now, as Pat showed this morning, we could not achieve this type of vision without a strict and broad collaboration with all our ecosystem. And so we're working on a number of initiatives with all our partners, some of which you see listed here, but there's many more, to drive some of the key technology innovations that we need to get to this point. So things like establishing broad support for a new solution like VirtualSAN with server vendors. Things like working on virtual volumes to extend the same level of automation to external storage. What are the key technologies that we're announcing today as part of VMworld 2013? First and foremost, VirtualSAN. As we said, VirtualSAN is a key component of the strategy, one that delivers the converged infrastructure layer. VirtualSAN is available today in the form of a public beta with a target GA date for first half 2014. We're releasing it in the form of a public beta because we want to achieve broad system testing and real-life validation from our customers. This is a Generation 1 storage technology. Storage is very important. So stores data, and data is the most important asset for our customers. And so we want to make sure that people get familiar with it and comfortable with its usage. So that's why we're starting off with a public beta program, which is kind of an exception for VMware. The second technology that we talk about is virtual volumes. Now, virtual volumes is not available today, but we are showing tech previews for what's coming soon. And you'll be able to show and see a number of partner demos about virtual volume implementations in the floor at the booth. In the area of application-centric data services, we are releasing two key products and features. First, vSphere Flash Read Cache. vSphere Flash Read Cache provides VM-centric caching, read caching for your applications to deliver storage acceleration, leveraging server-side flash. This is a capability that is available with vSphere 5.5, and that only requires you to add solid-state drives to your hosts to deliver read acceleration. The second application data service that we're announcing is Virsto. Virsto is the result of an acquisition that we did early in Q1. Virsto solves the problem of the I/O blender by sequentializing writes to external SAN. Writes tend to be the most expensive operation, tend to be the one aspect of the I/O traffic that causes most of the bottlenecks from a performance standpoint. And with Virsto, we're really seeing tremendous improvement in performance once you deploy. It's a software-only solution that deploys as a virtual appliance on top of vSphere. And in addition to the performance acceleration, also provides very efficient snapshots and cloning capability. In the next section, VJ will go over some of the details of these technologies. And with this, I'm going to turn it over to you.
All right, can you hear me? Okay. No? I feel like a rock star coming here, on stage, but this is storage, so same difference. So Alberto talked about and gave us an overview of what software-defined storage means to VMware and how we plan to enable it. I will go over some of the products that we're announcing today, namely VSAN, VirtualSAN, Virtual Volumes, and Virsto, and dig a little deeper into those products. And if time permits, we'll take Q&A towards the end. The first product that I'm going to be talking about is VirtualSAN, VMware, VirtualSAN, vSAN. In the previous section, Alberto talked about converged infrastructure as being one of the important components of our software-defined storage vision. vSAN is VMware's first foray into realizing the vision of software-defined storage, and it enables the creation of a converged infrastructure solution or platform. And so what is vSAN? vSAN is a scale-out storage system that's built into the hypervisor, built into ESX. And the idea of vSAN is to take ESX attached or locally attached storage disks and cluster them together to provide a pool of storage to store VMs on. Simple. This pool of storage that you see, we'll call it the VSAN Datastore going forward, looks and feels like a regular shared storage data store. And it's flash optimized to deliver performance for the applications. And vSAN is a software-only solution, and it uses industry standard components, as you can imagine, because it's built into the hypervisor. And the big value that we want to drive with vSAN is around management. And we have taken the approach of a policy-driven storage management with vSAN, and I'll talk about that aspect in a second. But before I do that, let me first give you a highlight of some of the salient features of vSAN. So first off, vSAN is a scale-out storage system. So what that means is that in terms of both performance and capacity, vSAN, you can scale both performance and capacity by adding more nodes to the vSAN cluster. And as I mentioned to you earlier, the pool of storage, the VSAN Datastore, for all practical purposes, looks and feels like any other shared storage data store. And it exhibits, more importantly, it exhibits all the properties of a shared storage data store, even though it entirely uses local disks. What that means is that features such as DRS, vMotion, vSphere HA, all those features work exactly as it does today with vSAN. The third component of vSAN is that it uses locally attached SSD or flash devices optimally as both a read and a write cache, so it's able to deliver the high performance required for applications that's running on vSAN. And as you would come to expect with any enterprise class storage system, vSAN does provide high resiliency and availability. So we've implemented a distributed RAID algorithm for availability, and there are no single points of failure within the vSAN cluster. And the last point to reiterate is that we have, and the killer feature with vSAN is that we have built vSAN from ground up around the notion of a VM-centric, policy-driven storage management. The benefit of having a policy-driven storage management is that it makes VM provisioning simpler, and more importantly, it automates the SLA management and the day-to-day operations that you would need for storage. So let me dig a little deeper into that aspect now. So this is what we have today: profile-driven storage management. How many of you are familiar with what we have today with vSphere around profile-driven storage management? Show of hands. Okay, few of you. So let me walk you through this. What we have. We released a feature called profile-driven storage management with vSphere 5.1, I believe. And the idea of profile-driven storage management is that we let you bucketize data stores, storage data stores, into tiers of storage. So gold, silver, bronze type tiers. And in addition to that, we let you create profiles per VM. And when you provision a VM with profile-driven storage management, the data store that matches the profile of the VM was used to provision the VM. So what that means is that a VM with gold profile would be matched to a data store that's gold, and the gold VM would be provisioned on the gold data store. So this mechanism simplified storage provisioning to a large extent. However, it had a major limitation. So the limitation that it has is that there's no way with profile-driven storage management to assign specific requirements on an individualized VM basis. So there's no way to say, hey, this VM requires XYZ, and let the system handle it. And so with vSAN, we changed the whole notion of profile-driven storage management, and we've taken the approach of a policy-driven storage management. And the idea of policy-driven storage management is that we let you, with vSAN, we let you create policies on a per VM basis. And essentially, a policy encapsulates what the VM requires. So things like availability, capacity, and so on, performance, and so on, is encapsulated in a policy, and we let you attach those policies on a per VM basis. And those policies are then sent down to vSAN, which will then ensure that those policies are always met throughout the life cycle of the VM. So what this does is that it lets you simplify the whole VM provisioning mechanism. So when a VM is provisioned, you just tell the system what it needs, and vSAN will ensure that those needs are met throughout the life cycle of the VM. And so while it simplifies VM provisioning, the bigger benefit is that some of the day-to-day SLA management operations that you would need on the storage side is completely automated by vSAN. And if you happen to go to one of the vSAN sessions today, you'll see this in action. And so, just to summarize, with vSAN, we've gone from a profile-driven storage management approach to a VM-centric policy-based storage management approach. And over the next couple of slides, I'll walk you through some of the screenshots that illustrates the points that I made. The first one is enabling vSAN. So how many of you know how to enable DRS or vSphere HA on vSphere? Show of hands. It should be everybody. Come on. Okay. With vSAN enabling, or with vSphere, enabling vSAN is as simple as enabling DRS, is as simple as enabling vSphere HA. So when you create a vSphere cluster, there's a button that says turn on vSAN. Literally, this is the screenshot. And when you click that button, vSAN is created. The vSAN Datastore is created. The screenshot here shows that when a vSAN Datastore is created out of local disks, it looks to vSphere and to the end user as any other data store. So all the stuff that you can do with a regular data store, you can do with a vSAN Datastore. And finally, the screenshot here shows an example of a policy being created. And just to walk you through an example, when you provision a VM on vSAN, we'll let you tell the system what kind of availability you want for the VM. How many nodes you want to protect the VM against. We also let you pick reserve a certain capacity for cache, read cache, for example. So there are a bunch of things that we ask you to specify on a per VM basis, and vSAN will ensure that those things are always met. And this is an example. The screenshot here is an example of the way a policy is being defined. All right. So just to summarize what vSAN is and the core and the unique value that vSAN brings to the table. Just to highlight a few points. The first one is I want to reiterate this point. vSAN is native to ESX. It's built into the hypervisor. So the implication of that is that vSAN is able to make use of internal resources efficiently, and more importantly, it's able to minimize the end-to-end I/O latency because it's built into the hypervisor. The second one is that I talked about policy-based, VM-centric policy-based management, but also the important thing to note here is that even in the guts of vSAN, in the way it's architected, we've architected vSAN around VMs and VMDKs. So all the data operations and all the data management functions, even at the heart of vSAN, is done at the VM or VMDK level. And finally, because vSAN is integrated with vSphere, it participates and it seamlessly integrates with our resource management function, DRS. So when DRS places provisions of VM where vSAN is enabled, it takes into account vSAN characteristics when making placement decisions for the VM. So to net it out, vSAN is a radically simple enterprise storage that significantly lowers the cost of storage for our customers, but without any performance compromises. And if you compare vSAN to the rest of the industry, vSAN performs at the level of a mid-range storage system, but at a much lower price point. So essentially, you no longer have to make a trade-off between performance and cost with vSAN. And speaking of performance, here's a chart that compares vSAN to an all SSD or all flash storage system. And what we are showing here is that this is a VDI deployment. This is, this chart shows a VDI deployment. And what we are showing here is that the VDI VM density running on vSAN is the same as an all flash storage system. What that means is the number of VMs that you can run on vSAN cluster is the same as what you could run on an external all flash storage system. However, the cost of vSAN is 25% of the cost of an external storage system, external all flash storage system. So similar VDI VM density at 25% of the cost. That's the key takeaway from this chart. And more importantly, particularly as it pertains to VDI and comparing vSAN to external storage, there's no longer a need to make a huge upfront investment with vSAN as you scale your VDI deployment. So as you scale from 500 VMs to 1,000 VMs and 2,000 VMs and so on, there's no longer a need to make these huge upfront investments every time you scale a VDI deployment, because vSAN is a scale-out storage system that with performance and capacity scaling linearly. You only need to make incremental investments as you scale your VDI deployment, and this is a huge benefit for our VDI customers. And finally, to close out vSAN, we are announcing vSAN as a public beta today. The beta site is online. Go ahead and register for it. It's free, and I believe you get a chance to win an iPad if you register for vSAN beta. All right. Also, I gave sort of a high-level overview of vSAN. We have a lot of sessions on vSAN this VMworld. These are 3 of them that I picked as deep dive sessions. Beyond going deep into vSAN, there is a customer panel session on vSAN that I encourage you to go and attend, because it gives you a perspective from your perspective, from our customers, how vSAN is used and how they used vSAN and how what they think of vSAN. All right, so that's vSAN. I'm going to move on to virtual volumes. All right, so I described the benefits of policy-driven storage management in the context of vSAN. Our goal at VMware is to bring the same benefits of policy-driven storage management to external storage as well. Okay, and essentially what that means is that we want to be able to provide the mechanism for you to create policies on a per VM basis, and which encapsulates the requirement of the VM or of the application. And instead of the policy being interpreted by vSAN, we want the same policies to be interpreted by external storage and be able to enforce those policies. And the way to achieve this is to move from a model where VMs are tied to LUNs to a model where VMs or VMDKs are native objects of the storage system, external storage system. If VMs and VMDKs are native objects of external storage systems, we can now enable data services and data operations on external storage systems at the VM or VMDK granularity. So things like replication, snapshots, caching, and so on can now be performed by your SAN and NAS system at a VM level or a VMDK granularity. And so that's what is virtual volumes. So virtual volumes is a set of APIs that essentially converts your existing storage NAS or SAN storage system into a VM-aware storage system. And what that means is that your storage system can now store these VM as native objects. And the benefit that it brings to the table is that we can automate SLA management on external storage, just as we have done with vSAN. We've also introduced a new control plane with virtual volumes that lets us communicate these policies down to the external storage, just as they've done with vSAN. All right, so just a screenshot on to highlight a very important point. The policy framework, the policy management framework that we are building is exactly the same between vSAN and VMworld. So what you saw with vSAN, and the screenshot shows this, what you see, the way you capture policies and the way you associate policies to VMs is exactly the same whether you have vSAN or VMworld. So this is a screenshot that just highlights that point. Some of you may know Virtualization because we have been working on it for some time. And we do have broad industry support, but with this VMworld, we have a number of our partners that have demos in their booths. So visit these partners visit these partner booths for a demo. How many partners are in this session? Half? Oh, come on. All right. Good. So, okay. So the last product that I'm going to be talking about is Virsto. So Alberto talked about app-centric or VM-centric, policy-driven, app-centric data services as being one of the important components of our software-defined storage vision. Virsto is a product that delivers VM-centric or app-centric data services. It comes in a virtual appliance form factor, and essentially it sits at the vSphere layer because it's a virtual appliance. It consumes external block devices, SAN systems, and makes it perform better, accelerates its I/O, and makes the performance of external SAN more predictable. The second value that it adds is because of the way the data is laid out in Virsto, you can now get high performance, scalable snapshots and clones at the vSphere level or the VM level. And so, just to give you a sneak peek, we do have a deep dive session on Virsto, but just to give you a sneak peek into what Virsto does and the way it works, essentially Virsto takes random IOs that come out of ESX through the IO blender, that comes out of the IO blender, sequentializes the IOs and sends it down to the to SAN storage. And Virsto's data layout, or its file system, if you will, is amenable for scalable snapshots and cloning mechanism. So that's what Virsto is. There's a session on it. Go and attend it to get a deeper dive on Virsto. The value that Virsto brings to our customers is that because it's able to provide predictable performance on existing SAN storage system connecting to vSphere, essentially you lower the cost of SAN because you no longer need to over-engineer your SAN or over provision it. And the second benefit that it brings to the table is that because it's all VM-centric management, your provisioning time decreases as well, and you no longer have to have you no longer have a trade-off between data services and performance with Virsto. So a couple of charts to show the Virsto performance. What I'm showing here is an experiment that we did with Virsto on an MS SQL workload on with a backend storage with a backend mid-range storage system, SAN storage system. And what we're showing here is that compared to with Virsto in the picture, the performance of the SAN increases by 110%, and the response time decreases by 93%. And more importantly, the amount of storage that's consumed on the external SAN decreases by 78%. And we see this over and over again with a lot of workloads. And finally, the chart here shows that no matter how many snapshots and clones you have taken with Virsto, the performance that you get out of the VM remains constant and steady. Okay. To sum it out, our approach to software-defined storage, three main components. A virtual data plane that allows you to abstract and pool storage either that's externally attached or local. A policy-driven control plane that lets you encapsulate the requirements of the VM and lets the right storage system do the right thing to enforce those policies. And finally, an app-centric approach to data services. So things like replication, caching, dedupe, and so on is done at an app-centric level. And the more important point here is that these data services can come from multiple places. It can come from your external storage, your convergent infrastructure pool, or could be delivered at the vSphere layer. So with that, these are the products that we're announcing today as a summary. And there are a number of deep dive sessions that I encourage you to attend on vSAN, virtual volumes, vSphere read cache. I didn't talk about it in this session, but there is a deep dive session on vSphere read cache as well as Virsto. So all right, thank you. If there are any questions, I don't know how much time we have for questions, but
just a quick announcement.
Thank you.